Thank you for joining us today and welcome to ProServeIT Academy. This is Data and Analytics, class number 1, Dimensional Modeling and the Star Schema. Data analytics has come a long way in recent years, and this class is designed to help you make actionable decisions from your data. My name is Betty Kwan, and I'm on the marketing team at ProServeIT. Presenting today will be Scott Sugar, Practice Lead for Data and Analytics at ProServeIT. Scott, I'll hand it over to you.
Thank you, Betty. So yeah, I'll be your instructor for today. And just a quick run through of the agenda. So we're going to start off with OLTP versus OLAP, and don't worry about the acronyms. We'll get into what these things mean. We'll go through the different data models that each of these concepts use. We'll do a little example to kind of ground this in reality. And then from there, we'll dive into dimensional modeling. What is it? What are the benefits you get from it? What the 4-step modeling process is. So how do you get started with it? And then we'll dive into a bit outside the dimensional modeling area. We'll get into data maturity matrix and the data customer journey. So how this moves through things. So yeah. OLTP versus OLAP. So what are these things? So OLTP, online transaction processing, and it can rapidly execute transactions at the same time. So really, most systems that you end up using on a day-to-day basis, your ERP, your CRM, online banking, any online shopping, most website backends, all of these are using OLTP system databases. They're very good at writing data very quickly, which allows for quick responsiveness when you're working with those systems. OLAP, these are online analytical processing systems, databases. You can query data for analysis using these, and the main use cases here are data analysis and reporting. And this is where the data warehousing world comes into play in that OLAP. So these are kind of different styles of databases that are widely used. So if we get into what the data models for these things are, so if you're looking at OLTP, as I mentioned before, these typically run many smaller transactions, often lots of writes to the database. And the data model that's most commonly used is third normal form. And this attempts to normalize data to reduce duplication of data and help avoid data anomalies. Now, this all might sound very abstract at this point. The next slide, we're actually going to show a quick database diagram to kind of land this into something a little more concrete for everyone. So don't worry if this isn't landing yet, just kind of giving a little background info. OLAP, so these are typically running larger data queries, so large reads from the database. The model in play is the dimensional model, also known as the star schema. And it attempts to denormalize data as opposed to normalizing it. So it denormalizes data, which allows for faster retrieval of large amounts of data. And it also allows for a more human understandable data model, which is really important as you get into things like self-serve reporting, democratization of data, those kind of buzzwords that you're hearing lots of these days. OLTP versus OLAP, it's an example. For this example, we're going to look at a grocery store. Now, this isn't a complete example, but it kind of gives an idea of why these, how these different data models are different. So just jumping into this, let's look at the 3 normal form, the OLTP system on the left. So you're going to have things like your invoice header, your lines of the invoice, the products. Let me pull up my laser pointer here. The products. You're going to have store, customer, address, quantity, province, country. Now, what you'll see here is that things are really split out. So a store is just going to link to an address, and that address links to a city, and that city links to a province, and that province links to a country. Now, the benefit of this is that if a store moved to a different address, you're just making an update, one small update here, maybe a small update to add some information here, and then you can link out to the city, city which you probably are already going to have, the province and the country. So you're not duplicating any data, and it's also minimizing the chance that you're going to have multiple cities with some misspelling. So you'd have like a Mississauga with 2 S's, and then you'd have a Mississauga with 1 S, these kinds of things. So it's going to minimize that potential for data error as well. And so this is the kind of database system that you normally see when you're dealing with things like CRMs, ERPs, website backends, online shopping, these kinds of things. When we get into the dimensional model, what you'll see here is that things are put into this kind of star schema. So if you can imagine, normally you have things here, and maybe you have a table up there, and everything is joining off of your main fact table. In this case, we're dealing with sales. So we're looking at sales for a grocery store, and we have all the information that constitutes a single sale. And easily we can link that to a customer or to a store or to a product. So now if we think of a reporting use case here, and we say, I want to look at my sales of apples by province. In the third normal form, what you now need to do is join from your invoice header to your invoice line, which is going to get you your quantity and prices and the store. From there, you're going to need to link from the invoice header out to the store table. Then you're going to need to join from the store to the address. Then you're going to need to join from the address to the city. And then from the city, you need to join to the province. So you're looking at 6 different table joins in order to see sales by city. If you know the data model really well, so you're someone that is working with the underlying database on a day-to-day basis, it's probably not that tricky. But if you're a business user that doesn't look at the underlying database, they just work with the application in question, your ERP, your CRM, whatever it is, you probably don't know that you need to make those 6 joins in order to see sales by city. So in the data warehousing world, because we've denormalized this and we have all sales data sitting in here, which includes your store ID, and then I can connect directly to my store table, and then my store table has city built into it already. I can just do a single table join and take my sales data and slice and dice it by city. So I could say with a single table join, it's nice and easy to then make a report where I bring in my sales and then I slice it by city. So it's a much easier human readable data model, as well as because you're not having to read 5, 6, 7 different tables, the query time to read that single table and maybe this table here is going to be much faster than in trying to read 7, 8 different tables to do that, to do the joins over there. So that's kind of trying to land, the differences between OLTP and OLAP as data models. So now we're going to get into actual dimensional modeling. So what is dimensional modeling? So we've kind of gone through OLAP, which is uses dimensional modeling, but what is this? So really what dimensional modeling is trying to do is to split the world or your data into facts, so events, and dimensions, the who, what, when, where. So if we go back quickly to this slide here, your fact is your sales. So this is the event that's happening, a sale of something. And then the who, what, when, where, why, the who, what, when, where, that's your customer, your store, your product. And these are the things that you're going to slice and dice by. So again, facts are the things that you want to measure. Dimensions are the context, how you want, and in another way of saying that is how you want to slice and dice, how you want to split up the things that you're measuring. So if we look at this, one of the goals of dimensional modeling is to reuse existing dimensions where possible. There's a bunch of reasons for this. The main ones mean that you can now look at different sets of measurements and drill across them. So you could do comparisons between sales and inventory, or comparisons between inventory and shipping, assuming that you're using the same dimensions across all of those different things that you're measuring. And it also allows you to build things faster by just plugging new measurements into your existing dimensions. This does provide, so this provides that underlying architecture for an enterprise data warehouse. And what we call this kind of layout here is the bus architecture, the enterprise bus architecture, and it shows you which things connect to, which measurements connect to which dimension. So we know, okay, sales, we can connect to store, customer, product. For our inventory, we can connect to a store and a product, but it doesn't necessarily connect to a customer. So it gives you kind of a high level picture of what's happening within your data warehouse. The benefits of dimensional modeling. So understandability. So again, we've kind of gone through this, but it makes the data model easy to understand and more intuitive. Query performance, which we touched on already. So this kind of data model, dimensional model, is optimized for data querying. Much easier to read a larger single table than 10 medium-sized tables. Extensibility. Because you are abstracting the data from the source systems, so the source system being your ERP or your CRM in third normal form, because we're abstracting away from that, it makes it easier for us to make changes to our reporting data models and accommodate new data or change a source system. So if your ERP gets changed to a new ERP, you can retain the same data model. Your reports don't break, and you can plug the data from your new ERP in and still see historic reporting all the way back from your old ERP through your new ERP and into the future. Consistency, as we kind of touched on before, with using the same dimensions across all of your different measurements. This means that your data is described in the same way across those different measurements. So you have a level of consistency there. And then the other thing we touched on was that in this dimensional model, you're able to do smaller pieces of work. So if you look back here, you could say, hey, I just want to, as an initial use case, I just want to tackle sales by store, customer, product. And you can tackle just that piece without having to go through a giant project that tries to model your entire organization. So you can pick a single smaller use case, build that out, and then you can go and build the next piece and build the next piece and slowly and iteratively build out. So it allows for smaller projects that provide value quickly. We've seen some organizations try and model their entire business, and that takes 6 to 12 months before you're seeing any value at all. And what we've seen is by the time you get to that 12-month, hey, I've finished modeling my entire organization, pieces of the organization have changed so much, or software products that are in use have changed, and your modeling efforts now have to be reworked. So it's nice to be able to kind of move fast and quick. Getting into the 4-step process. So step 1 is defining the business process. So are we looking at modeling our sales process? Is it our shipping process? Is it our inventory process? Is it our profit and loss statement process at the end of the year? Like, what are we trying to model? Then we're going to declare the grain. This means the granularity at which we want to show our data. So if we go back to here, we could look at this granularity at 2 different levels. So we could look at it at the invoice, the total invoice, so just the invoice header, or we could look at the line items, the individual line items. So again, if we're thinking of that grocery store scenario, do we want to look at this data, our sales data, at the level of an entire invoice? So we don't care which line items, which products the person purchased. We just want to see how much each customer spent in a single purchase. Or do we want to get down to every single item? They bought cereal, they bought apples, they bought this. Our recommendation is when you're doing your dimensional modeling, always go to the lowest level of granularity possible. The reason for that is if you go to the lowest level of granularity possible, so in that grocery store example, the actual line items, if you go down to that level, it's always possible to then roll up to the invoice level. But if you go at just the invoice level and you build your data warehouse around the invoice level, there's no way for you to then drill into each line item. So our recommendation is always, hey, go to the lowest level of granularity possible, build out what you can there, and then if you need to see things at different levels after that, you can always roll up. After you declare the granularity at which you're going to model your business process, you then identify the dimension tables. So what do I need to slice and dice my data by? And then you identify the facts. So what am I measuring here? Quantity, price, cost, those kinds of things. Typically what we see is you go through this process once, and then you typically hang out here for a couple iterations to confirm, hey, I've got all the things I want to slice and dice this data by, and I've got all of the things I want to measure. So it is a 4-step process, but steps 3 and 4, you typically spend a bit more time on and maybe iterate through a couple times. For further reading through, which is going to give you more information on dimensional modeling, the benefits, that 4-step process, what is it, all that stuff. What we recommend is for executives to read chapter 1 of this book. It's a pretty quick read, and it really gives you a great grounding in the why, the benefit, so what you're doing, the benefits, and that 4-step process. And then for technical people, we recommend going through the entire book, because after chapter 1 or 2, you start getting into use cases that show you how to model data and different edge cases and technical pieces like that along the way. And this book from the 90s is really the founding of all of this, of all of what I've been talking about so far today. So it's a good read if you're interested in this stuff. From there, we're going to dive into the maturity matrix real quick. So we're going to stick, ProServeIT does a whole bunch of stuff, as you can see there, across a range of different areas. We're just going to stick up here for now, this insights and automation area. So what we see with most clients when we meet them is that they're in that level 1 area. They're doing a lot of spreadsheet reporting. They've got complex Excel formulas all over the place. There's a lot of manual cut and paste. They find it difficult to integrate data from multiple sources without, again, having giant V lookups and if statements in formulas and cells that have to be copy pasted around. And then there's a dependency on key individuals for knowledge of that reporting process. And if those key individuals either leave the organization or go on vacation or maternity or paternity leave, something like that, those reports can end up being, kind of dead in the water, unfortunately, or require someone to spend a whole bunch of time trying to reverse engineer and figure out what was happening. So where we take clients as a first step is into level 2, which is creating an initial report set off of an initial use case, whether that's modeling your sales data or your financial data or your inventory or shipping data. We implement automated data retrieval and data refresh, so you're not having to copy paste anymore. You're not having to worry about someone rerunning the report once a week or once a month. And then allowing for easy integration of multiple data sources. So you don't have to worry about giant VLOOKUP if formulas. You're able to create relationships using something like Power BI or Tableau by just saying, hey, this column here connects to this column here. And then as we move into level 3, we have integration of external data sources. We have artificial intelligence, machine learning, and getting into mobile dashboard scorecards. So to kind of walk through some stories here. So we met a company in level 1 that had, there were a brewery that was selling products through multiple sources. They had a POS system for restaurant sales. They had an e-commerce system for selling merchandise online. And then they had a second point of sale system for selling products directly out of their brewery. What was happening is they had a real hard time being able to integrate data from all of those sources. So what they ended up doing was having Excel sheets, one for each different sales system. So one for their e-commerce system, one for their restaurant point of sale system, one for their brewery point of sale system. And if they wanted to see sales across their organization, they were essentially opening up multiple Excel sheets and just kind of eyeballing it. They had no way of connecting all of those sales together. So being able to then take that data from all of those sources, help them model their sales process, and then build out the data warehouse that allows for easy integration of data from all those sources, allows them to then have a report that shows sales across their entire organization, broken out by product or customer or city or anything like that, like we showed before. Working with clients in that level 3 area, so integration of external data sources, we've had clients that compete against public companies. And one thing they've done is take some of the financial data from those other public companies and allow them to compare what they're doing against those other companies and see how they stack up in the marketplace. There's other uses for external data sources in a similar vein to that. Pulling in weather data for some agri-food companies or things like that as well. And then into AI, artificial intelligence, machine learning. We've done work around price optimization for clients. We had a client with survey data that had free-form text areas that just allowed people to enter in, their thoughts and feelings on the product being sold to them. And there was no real way to quantify in a meaningful way how that person felt from that freeform text. There were some other value-based fields, but the freeform text was kind of a black hole. Layering in sentiment analysis to take that text and turn it into a 0 to 10 score, 0 being, hey, this person is really upset, and 10 being, this person is super pleased. Took that freeform text data and turned it into something that you could actually aggregate. So you could aggregate it and figure out, hey, here's a number that we can attach to that freeform text, so we can actually see how people are feeling about it, and then we can drill into specific cases for it or roll up across larger segments of the user base to figure out how people are feeling. And then mobile dashboard scorecards. We worked with a client that was doing a lot of meetings with clients, and they wanted their sales team to be able to get all of the information about a client as they were walking into the client's door. So they would have full up-to-date information on, hey, here's what the client has purchased from us, here's their satisfaction scores, here's a potential churn rate percentage, all that stuff, and they could see that on their phone as they're about to walk into the client. So that's kind of that level 1, level 2, level 3. So how people move through that, and then this is our kind of the standard customer journey that we take people through. So that step 1, we do a discovery, figure out where they're starting from. Level 2, once we know where you're starting from, we can help you level up from, if we find you at a level 1 in the maturity matrix, we can get you up to that level 2. So we can integrate data from multiple sources, create that single source of truth, and build a foundational data infrastructure. And then what we find is that the data journey is never done. Your business is evolving, your data is evolving, things are changing. So that we then work with clients and become an extension of their team, really, to help them continue to support what we've built and enhance and improve and get into that level 3 area of that maturity matrix. Start integrating external sources, start layering in artificial intelligence, machine learning, and all that stuff. That's what we've got for today.
Thanks, Scott. That was amazing. Really enjoyed the real life examples too. I want to thank everyone for joining us. And if you have any questions, you can always reach us at our general inbox at cloud@proserveit.com. Thank you very much.